Hello, and welcome to the OVS Conference 2021. My name is Adrián Moreno, and I would like to talk to you about how to improve flow debugging, both online and offline. Let's jump right to it. OpenFlow and datapath flows are a key component of OVS and OVN ecosystem, and yet they are quite difficult to reason about. They are dense, unstructured, sometimes unordered, and mostly delivered in plain text. So many times when you're looking for something, it's really hard to find. I don't know about you, but when I have to troubleshoot some problem with flows, I end up looking like this. I hope you agree with me that it's quite an eye-straining task. But it's not the only challenge that we find when debugging and troubleshooting OVS and OVN issues. Many times our favorite tools are just not available. The reason is very often we don't have access to the real life environment. Maybe it's in a customer site, or maybe it's just not reproducible at all. So we have to deal with logs, flow dumps, OVSDB database files, or log collection archives like SOS reports. The problem is our tools, OVS and OVN tools, just don't play nice without daemons around. So these two problems really make troubleshooting more complicated. And the result of that is that we take longer to analyze and solve customer cases and also to develop new features. In order to help out, we've introduced a couple of tools. First, I will briefly explain how OVS ofparse works, a flow parsing and visualization tool. And then my colleague Salvatore Daniele will show another tool called ovs-offline, which helps with offline debugging. So please bear with me while I first explain how the flow parsing library works, and then we'll see it in action, I promise. So first, the foundations. Most parts of the flow are basically key value pairs. The character that is used to split the key and the value sometimes differs, but it's essentially a key value. Other parts of the flows are lists, but when given a little bit of context, they are very easily convertible into key value pairs. The core library, therefore, is based on a key value object. We introduce some metadata that helps us find it in the original string, and the parsing is performed using two kinds of objects, a parser and a decoders. Decoders is a data structure that stores a function capable of decoding its value. And both the key value parser and the list parser are generic classes that split the string into key values and uses the appropriate function to decode it. The result of the decoding is either a Python type or a special type that supports masking. Here's an example. As you can see, we take the flow, we split it into 3 sections, and each section basically contains a list or dictionary of key value pairs properly decoded. The library also contains a filtering engine. A filtering syntax is defined that supports logical operators and also comparisons. Comparisons are basic arithmetical comparisons, and a special comparison that has a tilde symbol that supports masking. Now, I would like to talk to you about the tool that is written on top of this library. It supports extensive styling. You can use a configuration file to pretty much define the color in which you want each key value to be printed. It supports filtering, of course, and it supports outputting the flows in many different formats. So let's see this tool in more detail. Oh, it's right. I promised you a demo, so here it goes. So here I have an OF proto dump. So as you can see, we have a bunch of flows that are difficult to visualize. First, let's see the help. So we have input, some filtering and highlighting, and it supports datapath and openflow flows. So -I, let's see what we've got here. Console is just the basic console output. It looks very similar to the original file, and it supports styling. So I have defined my own style here called dark, which looks nice in my opinion in this dark terminal. Just highlights the keys and values, prints some of them in green, some of them in red. It's a way for me to try to focus on the relevant parts of the flows to start with. We can also filter. So for instance, I see an IP address there, so let me filter on that IP address. So destination. Yeah, I can filter on a single IP address, and I can use the tilde to filter on any flows that contain this IP address. For instance, this flow with this net mask contains the IP address I'm looking for, so I can quickly find it. What else? We can also look, of course, create more interesting filters, such as end bytes, greater than 0, and drop. And we can highlight any field, for instance, the table that is that each flow belongs to. Now let's look at another format. Let's look at the logic format. The logic format, as we can see, collapses a number of flows into what we call a logical flow. It has nothing to do with the OVN logical flow, by the way. It's just a way of grouping flows that have the same set of matches and the same set of actions, regardless of their arguments. That way, we can understand what the table is actually doing. Like for instance, take table 8. In fact, let's just focus on table 8, right? We can see here that there are up to 30 flows that have been collapsed in 5 logical entities that have the same matches and actions. So now we see that there are 5 flows filtering on VLAN information, another 5 flows filtering on source MAC address. So we can probably say that table 8 has something to do with port security, just by looking at this logical representation. This format allows for some additional options, such as show flow, for example, that does exactly that. It shows the flows that belong to each logical entity. So then you can go ahead and look at the details, at the different values that each flow compares against. Additionally, it supports Heatmap. The Heatmap option prints the number of packets and bytes using a color that depends on their relative value. So big values, like the flow that is hit the most, will be printed in red. Low values will be printed in blue, and values that are in the middle will be printed in greenish, yellow, or cyan. We also support printing Asian format, which does what you expect. outputs each flow in the JSON format. Also, we support HTML format. HTML format can be used to share the flow table with your colleagues, or maybe append it into a test result web page. So let me output the flows to a file and print it here and show it here. So it supports styling. So but I have another style that looks better in HTML. So let me refresh here. There we go. Just a normal table that has some hyperlinks for easier navigation. Let's see what else. Let's look briefly at data path flows now. Data path flows can be parsed using the data path option. And as you can imagine, the console just adds some styling and nothing too fancy. And the logic representation of data path flows, what it does is it groups data path flows in a tree structure based on their recirculation ID. So whenever a flow hits a recirculation action, we put the flows with that same recirculation ID underneath that flow, creating a flow tree. And we color that value with a specific color so that your eyes can follow the tree easily. As a side note, just also note that filtering on this tree is a little bit different. We cannot just filter out those flows that do not match our expression, because we would leave kind of a confusing partial tree, right? So if I do something like output port equals eth0, as you can see, this filters out a number of flows, but it will show the entire tree that contains one flow that matches that expression. So even though this flow, for instance, at the top does not match the expression because it does not output any packet to port eth0, this one does, and that makes the entire tree be printed. We also support data path being printed in HTML format. And in this case, the flow table has some nice collapsible features so that you can, for example, collapse the entire table and just focus on one subtree in order to further investigate the problem that you're dealing with. So that's it. Thanks for watching, and I leave you with Salvatore, Daniele, and ovs-offline. Thanks.
Hello, my name is Salvatore Daniele. I work as an intern on the networking team here at Red Hat, and today I'm going to be presenting to you a tool called ovs-offline. So ovs-offline works by recreating an offline replica of a live OVS or OVN setup. So it's a series of scripts that collects OVS and OVN information from either a live setup or an SOS report, and uses that information to recreate the OVS DB server, the vSwitch daemon, and the OVN northbound and southbound databases in containers, so that we can then run our OVS and OVN tools against the offline replica to analyze and debug as if we had access to the live setup ourselves. So for example, rather than looking through logs or going back and forth with the customer for information regarding what's going on in their OVS setup, we can recreate their setup using ovs-offline and then do something like run an OF prototrace against the offline replica to determine how a certain type of traffic would be handled in their system. We also have access to tools like OVS VS Cuddle, OVS DB Client, and some OVN tools like OVN northbound and southbound cuddle. So this is a super useful tool to determine what's failing in a system or for debugging and analyzing a live OVS setup that we are not able to access directly, such as in the case of many customer issues. So OVS offline is designed to be super simple in terms of the usage. It's essentially 2 steps. The first is to collect the data. So we need the flow dumps, the group dumps, the TLV maps. For anyone who's familiar with the OVS save utility, that's essentially what we're doing here. And then we need the databases. So we need the OVS database, the OVN northbound, and the OVN southbound database. So currently in OVS offline, we have a few commands designed to collect this data directly from either a live system in the case of OVN Kubernetes or OpenShift clusters, or from an SOS report. So in the case of the customer issue, the customer can generate an SOS report on their OpenShift or OpenStack cluster, send that over to us, and we're able to recreate the offline replica directly from the SOS report. We're able to collect all that data, and then we run OVS offline start, which automates the process of creating that offline replica, standing up those containers using the information we've gathered. So to show just how quick this is and just how easy it is to get OVS offline up and running, I've put together a quick demo using an OpenShift cluster. I collected the information from the OpenShift cluster using the SOS report, and I'll demonstrate just how simple it is to run a few debugging tools with OVS offline. All right, so I've got my live OpenShift cluster, and I'm going to replicate this cluster using OVS offline via the SOS report. So I've got a few master nodes, a few worker nodes, I've got some services running on those worker nodes, and I've got this net test pod that I use to generate traffic against those services. I've also got my SOS reports saved locally, one of which was collected from worker 1, which is going to give me my OVS information, and then the other from master 1, which is going to give me my OVN information. So in the case of OpenStack and OpenShift, you will need both. So now we can run OVS offline collect SOS OVS, specifying the worker SOS report. And this is going to give us our flow dumps, our group dumps, our TLV maps, and our OVS database. And now we can run OVS offline collect SOS OVN, this time specifying the master node SOS report. This is going to give us our OVN northbound and southbound databases. And all of these files are going to be saved into our working directory, which is temp/OVS offline. So now we can run OVS offline start. It's going to check our working directory for the necessary files, which it will use to stand up our containers. So we've got our OVN northbound, OVN southbound, OVS DB server, and our OVS vSwitch D. And there we go. Now OVS offline is live. So as you can see, here are all the commands available to us: OVS app cuddle, OVS VS cuddle, OVS DB client. Currently, we do have to run these, specifying the sock file to run them against. But we've also added this convenient shell script, which you can source like so, to now run these commands directly. So what that script really does is set a few environment variables, namely OVS run directory, which, as you can see, now points to our working directory. So if we actually check inside this directory here, temp/OVS offline/var run/OVS, here are all the corresponding files from our offline replica. We also have the same for OVN northbound and OVN southbound. If we want to check, we can run docker ps, and we can see our 4 containers running here. So we've got our OVS vSwitch D and our 3 OVS DB servers. And so now we can run a few commands just to show that this is in fact a working replica. So we could run OVS VS cuddle and try and find that interface that corresponds to the net test pod. And there we go. We've got our IP address, we've got our MAC address, we've got our openflow port. We could try an OVN command. So we could do OVN northbound cuddle show, try and find the logical switch associated with worker 1. And there we go, we found it. We also have this MAC address that corresponds to this attached router. So we can use that information to run an OF proto trace. So I've got this trace here, which is going from our net test pod to the router MAC with this network destination of one of those echo deployment services running. And there we go. As you can see, we are able to run OF proto trace. It outputs to openflow port 41. We could do OVS app-cuddle DPIF show. OpenFlow port 41 datapath 382 corresponds to this interface here, and we can do OVS vscuddle find interface. There we go. This is in fact one of our Echo deployment, one of the pods backing our Echo deployment servers. So there we go. Our environment is working as expected. Cleaning up is also super quick. We can just run deactivate to get out of that shell environment, and then OVS offline stop will automatically clean up all of the containers and delete the work directory. And that's it. That is OVS offline in action. So to wrap things up, I'll cover a few of the limitations of OVS offline. Notably, one of the primary tools of insight into the live OVS setup is OF Prototrace, so there are some limitations that come with OF Prototrace. For example, it lacks a contract module, so we're left to speculate what the CT state would be in the live OVS system. We currently have to set that manually with CTNext when running traces. Also, when a trace is run that results in the packet being handled by the OVN controller, well, we have no way of knowing how that packet would actually be handled. There's also some limitations to OVS offline itself. Obviously, we don't have access to the kernel running the live OVS system. We're using a dummy system instead, so we don't have access to the data path information. There's some inconsistencies in some of the commands, such as if you were to run OVS app-cuddle DPIF show, those data path ports listed in those interfaces might not correspond to the port numbers in the live system. So here's the link to the OVS debug repo if anyone would like to learn more or better yet contribute. We have a long to-do list of issues we want to resolve and features to add. So with that, we'd love suggestions, issues, questions, any kind of feedback. If you have an additional logging format that would be useful to start OVS offline from, like we currently do with the SOS report, if you think this would make a good addition to the OVS tree, if this just may be of use to you, please let us know. And thank you very much for your time.
And welcome back. We now have time for questions. So Adrián, and if we have our other speaker online, if you'd like to turn on your video and audio, we have a few minutes for some live Q&A. So one of the questions we have here from Gaetan Rivet is, would there be a way to recognize the OpenFlow or data path format automatically? Do either of you have any thoughts on that?
Yes, definitely. We should be able to recognize automatically which format is the flow that we're parsing. So yeah, I think yeah, we could do that, and we could simplify. That would simplify the CLI. True. And yeah, good suggestion. Thanks. Any other suggestions? Feel free to just answer on the RFC or the series that has been posted to the list.
Great. So we have one more question in the Q&A that hasn't already been answered, and that is from Jacob Libosfar, who asks, how does the heat map consider a high amount of packets to highlight it red, for example? Does it depend relatively on the amount of packets that enter the flows, or are there hard thresholds?
There are no hard thresholds, so it's all relative, the relative size of that number. So in fact, the heat map is considered after filtering. So if you want to first specify a filter and then add the heat map option, you will get the relative size of that number only on those flows that have passed the filter.
All right, thank you. So that's the time that we have for questions for this talk. So we need to move on to our next